Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at how to draw and represent electrochemical cells using conventional cell notation. We're going to talk about the usual or conventional way cells are drawn and the notation used to represent them, given examples. Electrochemical cells, standard electrode potentials, and salt bridges have been covered in separate videos. Check the links in the description below. When drawing out an electrochemical cell, usually the half cell that undergoes oxidation is drawn on the left of the diagram and the half cell that undergoes reduction is drawn on the right of the diagram. This doesn't always have to be the case, however, and sometimes they are drawn the other way round, even in textbooks. This is why it's really important to understand what's happening in half cells and electrochemical cells. Drawing out these diagrams is time-consuming and takes up a lot of space on a page. To make things easier, they can be represented using something called conventional cell representation or notation. Each half cell is represented in a simple form that is based on the species that make it up, showing the solid electrode material and the ions in the electrolyte. The species in different states or phases are separated by a short vertical line, representing a phase boundary. For example, an iron half cell with a solid iron electrode with Fe2+ ions would be Fe solid line, Fe2+ aqueous. Species in the same state but a different phase can also be separated by a comma. For example, an Fe2+ and Fe3+ half cell with a platinum electrode would be PTS solid line Fe2+ aqueous, comma Fe3+ aqueous. For any given electrochemical cell, the two half cells are drawn with a double line separating them. This represents the salt bridge and effectively separates the two half cells clearly. Because the oxidation half cell is drawn on the left, we show species getting oxidized from left to right. And for the reduction half cell on the right, we show species getting reduced from left to right. For example, with a zinc and copper electrochemical cell, in the zinc half cell, the zinc solid will be oxidized to zinc 2+ ions, meaning this half cell would be on the left side of the salt bridge and would start Zn solid, followed by a line, then Zn2+ aqueous. For the copper half cell, however, Cu2+ ions will be reduced to Cu solid, meaning on the right side of the salt bridge we would write it as Cu2+ aqueous, line Cu solid. Overall then, Zn solid line, Zn2+ aqueous, double line, Cu2+ aqueous, line Cu solid. This is showing zinc being oxidized to zinc 2+ in one half cell and Cu2+ being reduced to Cu in another half cell, with the two half cells separated by a salt bridge. When dealing with cell EMFs or electromotive force, the sign of the EMF tells you the sign of the right-hand electrode in the diagram. For example, a cell EMF of positive 1.10 volts for zinc and copper tells you the copper electrode is the positive electrode, a positive sign. And as a result, you then know that the zinc electrode must be the negative electrode, a negative sign. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit ChemistryStudent.com for free notes and revision materials.